Even if you're new to mobile development, you are already testing. When you're done with a feature, what's the first thing that you do? You try it out to see if it works. That's a manual test. The problem is that as your app grows, it quickly becomes time-consuming and error-prone to run manual tests for all the features, layouts, all languages, etc. You can avoid this by creating automated tests. They are small programs that verify the different pieces of your app. Beginners might think this is a waste of time, but there's a reason why big apps have a similar amount of code shipped to users as they do for tests. So, why do we automate testing? Quality is a big reason. Sometimes we catch bugs by creating and running tests, but most of the time we do it to make sure we don't break features in the future. And that brings me to the main reason why it's important to have a good testing strategy: your own productivity. It reduces the time you have to waste on manual testing or future debugging and gives you fast feedback. More productivity leads to more time for the important stuff. Now, depending on your testing goals, you have to take different approaches, so these videos will help you choose the right one in every situation. Let's see what you can do to start creating or improving your testing strategy. If we're going to talk about testing strategies, that means, of course, looking at this testing pyramid, which shows the distribution of the number of tests per category. But this one has multiple problems. Why are integration tests in the middle? What is an end-to-end test anyway? This pyramid doesn't help us create a scalable strategy. Scalable here means that all the decisions are made so that tests are reliable and run quickly, so you're not blocked when scaling your app. So, I'd like to present to you a different pyramid. This is the testing pyramid recommended for Google Apps internally, and as you can see, it has 5 layers and a lot more opinions than the other one. Not every app can follow it strictly, but it's a good baseline for scalable strategies. We broke the tests into 5 categories. Before diving into their attributes, let's talk about their general properties. The size of the tests increases as you go up the pyramid, not necessarily the scope. We'll talk about that in a minute. Also increasing our fidelity, which means how close the execution environment is to what users will see, and integration level. Consequently, tests run faster and are more reliable at the bottom layers. Given that our goal is to maximize productivity, speed and reliability are really important, so why don't we just create unit tests for everything? Well, we have to be pragmatic, and there is no way, or it's very difficult, to fully test an app without testing the integration between components, so each layer tests different things. Also, we should note that not all apps are going to let you create a pyramid if we count the number of tests per category. For example, a media player might have a lot more application tests and not that many components, so it will have fewer component tests. As a side note, let's talk about scope and size, because they're not the same thing. We'll focus on this example, a calculator app that shows an error message when you divide by 0. The app has a function called division that checks if the denominator is 0 and returns the appropriate division result. This needs to be tested, obviously, as you could be returning the wrong error. We could create a UI test that opens the app on an emulator, clicks on the buttons to generate the error, so 1 divided by 0, and then take a screenshot of the result. We'll talk about screenshot testing in the next video. And yeah, the screenshot test would cover our statement, what we wanted to test. But it's also going to start an emulator or whatever runs Android, an activity, render a UI, interact with it 4 times, take a screenshot, and compare every pixel. If we use this approach for all, say, 100 different errors across operations, we would need 100 different screenshot tests that could take minutes to run. The size of this test is massive compared to what we want to test, which is the scope of the test, the if statement. So going back to our pyramid, this screenshot test would be pretty big and placed somewhere around application tests, given its size. However, if we create a simple JVM unit test, it would take milliseconds to run. A unit test would have a very small size, so it would match the scope of what we want to test much better. Even if we create 100 unit tests, they would be fast, simple to understand, and easy to maintain. So I think that example is pretty clear, but what about the screenshot test that we described before? We still need a way to verify that the UI renders the error messages correctly, and a JVM test is not going to be enough. Also, we need to use different themes, form factors, font sizes, locales. So in this new test, we want to verify the UI. So the scope is now bigger than in the previous case, which was just an if statement. But in my opinion, this test is still too big. Do we need to inject user actions? Do we need the whole UI? The only thing we need is the calculator screen, the font, the color, the position of the error, etc. And because Compose is declarative, if you follow the best practices, you should be able to pass a composable the exact state needed to produce this UI in isolation without injecting any clicks or actions. So by doing this, our UI test now is a lot smaller, and it can be considered a component test, for example. This doesn't mean that we're done. The feature will probably require more component tests and bigger integration tests as well, but because we have covered a lot of cases in lower layers, we can limit the number of big tests, which is what we wanted, an actual pyramid. Now let's define each category in this pyramid. From the bottom, unit tests have minimal dependencies. They run on the host machines or your workstation or CI server. They don't access the network. The build type is debuggable, the ownership is the immediate team, this is important, and they are executed before a merge. Nothing surprising there. So let's move on to the more novel categories. Component tests are slightly bigger, and they might test the integration of multiple classes. They can run on emulators or Robolectric, and the rest is the same as unit tests. Of course, if you create your own strategy, you can add more attributes to the categories. For example, whether they can be screenshot tests or not. So how are they different from feature tests? Feature tests include external components in their scope and add real devices as possible targets. You can test the integration with a mocked network, and the ownership is shared with other teams. Obviously, your test strategy might not care about ownership, but it's useful to define who owns what, especially when you have a big team. All right, let's move on to application tests. They are big tests where you throw everything in: network calls, authentication, navigation, state restoration, tablet layouts, foldables, etc. They only run on Android, not on JVM, and they can hit backend servers. Fast tests are run pre-merge, and slow tests can be run in a nightly run or after merge. And finally, release candidate tests are very important because they're the only ones that use a release build, so a minified or optimized binary. It's very easy to release an app with a bug because of minification or bad Prograde rules. You can run these tests daily or when you have a release candidate. And we're done. The goal is not for you to follow this particular pyramid, but to make it yours. Write down a strategy document and share it with your team. You can merge layers or add a manual testing layer on top. This is not about creating strict guidance, but sharing a common language when talking about tests, and splitting the ownership so that no tests are left unmaintained. You can read more about the pyramid and testing strategies in the documentation. Now you hopefully understand the importance of a testing strategy, but in order to write one, you need to understand the different tools available to you. So check out part 2 of this series. Thanks for watching.